The second part of our notes is going to be about measurements. Every measurement is a comparison between an unknown and a standard, and that standard that we are going to use in physics is the metric system. It's based on units of different sizes related by powers of 10. We've got three base fundamental units in physics. The first of those is time, and the unit for time is going to be the second. It will be abbreviated with an S, and I'm going to be really consistent this year about putting all of our units in brackets to make them more easily recognizable. So you'll see that throughout the year. The next standard unit for physics is going to be length, and it's measured in meters, and we will abbreviate that with an M. And then finally, we're going to have the mass, which is in kilograms. And I know some of you guys might be wondering why we use the kilogram instead of the gram. It's because it's a practical reason. A gram is so tiny that if we were to measure, say, a paper clip, that would be about a gram. So a normal object that's going to have a lot more mass to it would be several thousand grams as a normal standard. So that's kind of a lot to work with those big numbers. So the scientists that determined the SI system decided that a kilogram was much more practical. So that will be our base unit for mass. We also have a little bit more information. All of the physical quantities are in terms of base units. So for example, if we talk about velocity, that's something that's measured in meters per second. And notice that it's a combination of the base unit for length, which is meters, followed by the base unit for time, which is seconds. So it does still derive from that. We're also going to learn about the Newton in one of our upcoming chapters, and that's also derived from the base units. You've got kilograms, meters, and seconds all combined, but that's something we're going to talk about later. When we use scientific notation, this is a convenient way to shorten numbers that might have a lot of zeros. Typically, you'll see scientific notation written as some number, so the first number is going to be between 1 and 10, times 10 to a number with an exponent. So for example, if we took the mass of the Earth, we would say that it is 5.97, because that first number needs to be between 1 and 10, and then times 10, and our exponent is going to be determined by the number of zeros that we have. In this case, to move our decimal over to be between the 5 and the 9, that's going to be 24 places to the left, so that would be a positive 24 for the exponent. Now there's a few different ways you can type this on your calculator. One such way is to type 5.97 times 10 caret 24. On your calculator, you also have the option of using the easy exponent key. So you would type 5.97, and then there's a button on the TI calculators that say EE, and then you would simply type 24. What this looks like on your calculator screen would be 5.97 e to the 24th. So those are a few different ways that you can type on your calculator. I would suggest using the EE, the easy exponent button, simply because if you're dividing by a number in scientific notation, you don't really have to worry about the parentheses. For example, if I were to divide by this number, and I typed it in my calculator 1 divided by 5.97 times 10 caret 24, I would need to include parentheses around that entire number. Otherwise, my calculator would divide by 5.97 and then multiply by 10 to the 24th. Versus if you use the easy exponent key, it's like as if your calculator is plugging in the parentheses for you. So it's just a little bit easier. And remember, if we move our decimal to the left, the exponent is going to get larger, just like we did in our example with the mass of the Earth. And if you move your decimal, let's scratch this one out. This one should say to the right. So check your notes. If you move the decimal to the right, then your exponent will get smaller. Since most of you probably have experience with scientific notation, I'm going to leave you to do these examples on your own. If you do have difficulty in figuring out what the correct answer should be, make sure that you make a note of that and that you ask me about it in class when we review what the section of the notes was over, and we can go over those together and make sure you have them right. These are some mathematical notations that you might run across. I'm sure you've seen equals, less than, and greater than before. I wanted to highlight this Greek letter delta that looks like a triangle. It indicates a change in a quantity. We're going to see that come up in the next chapter. We also have something new. This is sigma, the Greek letter. It looks kind of like a capital E, and it represents the sum of several quantities. So if you've used Excel or Google Sheets, you might have seen that when you go to add different cells together. And the last one is an alpha, and this is something that means is proportional to. So when you're comparing two quantities, you can say, for example, that mass is proportional to weight, and it means that you can compare two quantities on parts of an equation without necessarily having them equal to each other. We're just comparing their proportionalities. Next, we're going to work a little bit with percentages, decimals, and fractions. And the word percent actually means per 100. So that's just something to keep in mind. Whenever you see the word per, you're going to divide by, and then in this case per 100, you would be dividing by 100. So if I saw the example of 40%, I would take 40 and then divide it by 100, and that would convert it to a decimal. If you're going backwards and converting a decimal to a percent, then you would multiply that decimal by 100 and then add the percent sign. I'm going to do one example with you. In this case, we're converting percentages to decimals. So you simply take the percent, which in number 1 would be 25, and you divide it by 100. And this would give us an answer of 0.25. So go ahead and pause the video and try some other examples on your own. Make sure to keep track of the ones that you don't understand so that you can ask me about them in class. This section of practice questions is going backwards. Now we're converting decimals to percents. And again, I'm only going to do one example with you, so we'll take this first one of 0.1. To change that into a percentage, we're just going to take that number and multiply by 100. And in this case, that's going to give us 10, and then you write the percent sign afterwards. So go ahead again and pause the video and try the rest of them on your own. Make sure that you keep track of any of them that you have trouble with, and we can go over them in class or in tutoring if you're having some difficulty. For this section on prefixes, please memorize all of the power of 10 values and symbols for the prefixes listed in this chart. It is something that we are going to use throughout the entire year, so this is something that you'll want to get some practice with. There are a couple of listed at the bottom of the chart, so I'm going to go ahead and move those up for you, and you'll probably want to pause the video at this point so you can fill in the entire table. Now that you've had a chance to fill in the table, I wanted to point out a couple of things. This symbol right here is called micro. It's a Greek lowercase letter, and it looks like a U with a little tip in the front of it. And I know you've been working really hard, so I thought I would throw in a couple of jokes for you. So I'm just going to scroll these out of the way and see if you can use your power of 10 knowledge to figure out these riddles. I hope you enjoy them. You're welcome to pause the video while you try to figure them out. If you get stuck on any, be sure and ask me about them in class, because I love to hear people laugh. The last thing that we're going to do is learn how to convert between the various prefixes and power of 10 values. Now, some of you may already know how to do this, but I'm going to show you a shortcut. If it helps you, you're welcome to use it. If you're already really good at converting, feel free to stick with whatever method works best for you. But this is going to be the shortcut. What we would do, we have this problem of converting kilograms to megagrams, so we're going to start by writing the number given as is, so 750, and then times 10. All of our work is going to be done up here in the exponent of the 10 value. What we'll do is start with the power of 10 value for kilo, which is a 3, and then here's the key. We're always going to subtract. Okay, so I'm going to write that for you. We always subtract. And our next exponent, it comes from mega, which is a 6. Okay, so that's going to leave us with 750 times 10 to the, and then 3 minus 6 gives us -3, and then we would have megagrams as our answer. And I understand that this isn't correct scientific notation. You're welcome at this point, then you would move your decimal over and change your exponent as needed. For our second example, we've got 21 meters to centimeters, so we're going to say 21 times 10. Notice that there's no prefix right here in front of meters, so what we're going to do is our exponent will be a 0. Okay. And then remember, we always subtract. Centi is -2, so that's going to leave us with 21 times 10 to the 2 centimeters. I'll do one more with you. We're going to have 14 picometers, so we'll write down 14 times 10. Do you remember pico's power of 10 value? It is to the -12th. Okay. And then we're going to subtract. Milli's power of 10 value is a -3, and that's going to leave us with 14 times 10. And when we look at all of the work done in the exponent, -12 minus a -3 ends up being -12 plus 3. So that's going to leave us with an exponent of -9 millimeters. And again, you can move your decimal over and change your exponent to make it correct scientific notation. This is just a quick way to show you how to do a conversion. There are 2 more for you to practice on your own. If you're having problems with them, please come into tutorials in the morning or after school, or be sure and ask me about them in class when we go over the notes.